Assalamualaikum warahmatullahi wabarakatuh. Greetings for all the presenter of Information System International Conference 2023. My name is Rahimatul Wahidah. I will give presentation from the result of our research. The title is an artificial intelligence-based application for recognizing and identifying aerial objects based on voice inputs. Our team members consist Mr. Lukman Avandi, Mr. Arwinda Tumaya Wahyudi Sumari, Mr. Abdullah, Miss Inayati Maksus Iza Adin, and Mr. Muhammad Al-Fulkir. The outline of the presentation: first, introduction, the second, related words, and then extending conventional visual aircraft recognition. The fourth, system implementation, operation, and testing, and the last is conclusion. As we know that the detections of the presence of aerial objects in a particular region of airspace can be easily carried out by radio detection and ringing or radar if the object is within the scope of the radar signal. But in some conditions, aircraft intentionally hide in the radar shadow or fly low above the ground to avoid being detected by radar. It is needed a technique to recognize and identify objects that fly out of the coverage of the radar signal, such as an observation using binoculars from ground to air or air to air, depending on the situations. As we can see on the picture, we need to observe the object that fly out of the radar scope. We need to find out, is it a friend or is it a foe? To know that, it will be risky if we send an aircraft to find out, to get close to the objects, because we don't know, is it a friend or is it a foe? How if the objects have ability to attack us? But on the other hand, it will be have a low possibility of accuracy due to the limitation of human visual abilities if we observe in a certain design in a certain distance, which is considered safe. Moreover, the personnel who observe need a specific skill and then need to remember all the various types and characteristics of the objects. It will cause a high memory load for the personnel. Based on the above findings, a computer application for aerial object recognition and identification system based on AI technology equipped with a voice-to-text to prediction is designed and implemented. In situations that requiring speech, the achievement of prediction through voice will be faster than writing, especially for the GTA observer or pilot. In simple terms, this system will have three capabilities: converting the voice instruction into text form as the inputs to the system, processing the text inputs up to prediction that include displaying the prediction result verbally and visually through the screen as the basis for recognitions, and then the identification of the object. The related works and the position of our roots is all of this, and the position of our research focus on the development of artificial intelligence-based system for the recognitions and identification of aerial objects using voice inputs. The working mechanism of the proposed AI-based system. First, the observer bridges from ground to air or air to air, observe the detected UAA or unnamed aerial aircraft. They, the observer, will speak the observed features one by one through the microphone. All of these features, one, two, three, four, and then voice to text device will capture the spoken features. The AI-based system then process the features by carry out the recognition that ends with the identifications. Before the AI is used, a training series must already be done because machine learning needs to it. And then the result of the recognition and identification will be conveyed to the decision makers through sound via speakers or headset and displayed through the display screen in the command and control. This is the steps that I've said before. We use naive Bayes classifier for the AI process. You know that naive Bayes classifier is machine learning that carries out a probabilistic computation based on Bayes theorem and will compute how high the probability of a hypothesis is given single or multiple observation data. In MBC, it is assumed that each feature gives an independent and equal contributions to the hypothesis. The hypothesis is the target class of the observed data. Each feature is individually given an equal contributions to the observed data to become part of particular class. We use voice recognition, of course, and how to measure the accuracy. Google speech to text as the voice to text tool to convert the observed features spoken by the observer to the required text input. The accuracy of the resulting text converted from the observer's spoken words is measured by using word error rate, which is measured the word error percentage because of substitutions, insertions, deletions of the total word process, where H is the total hits or the number of the correct words, while N is the total words inputted. I occurs when the system captures a word that is not spoken. D is kept. D is the uncaptured word by the system, and S is when the system captures the word but does not match. Some factors, of course, affect the quality of the captured words from the ones spoken, including the quality of the microphone, the quality of the recorded spoken words, pronunciations, background noise, lousy articulations, and need more confidence. Here, the implementation of AI-based system is using Python programming language. The procedures have been taken for machine learning, the training and testing phase. The scenarios to test the feasibility of the system. The first one to test how well the system captures the spoken input. The second one to test how accurate the system in recognizing and identifying the observer UAA. It calls spoken words capture accuracy, and the second one is prediction accuracy. Okay, the spoken words capture accuracy. The aim is to test to know how well the system captures the spoken words. The system achieved were 4.16% or is very accurate. And then prediction accuracy. By using the confusion matrix symbol formula, the system got 79% accuracy. Okay, the conclusion. In this research, AI-based system for recognizing and identifying UAA as a critical tool to assess military personnel in GTA surveillance mission is successfully developed. The system takes voice of GTA personnel as input during the observations, spit up the data input into the corresponding input form, utilize it with machine learning to recognize and identify the UAA. With 70 UAA data and each feature, the system can achieve a prediction accuracy of 79% and a worst of error rate of 4.16%. I think that's all for my presentations. Thank you. Assalamualaikum warahmatullahi wabarakatuh.